Hello there everyone, and welcome to this equation explainer video on the wave equation. We're going to learn a really fundamental and important equation which can be applied to all types of waves. And I say that because when students learn this, they often assume it only applies to, say, light or sound, but actually it applies to any type of wave. Water wave, waves on a string, on a slinky, anything will obey this equation. It's a really important one that you should know. Let's get to it. The wave equation is all about how we might calculate the speed of a wave. And in simple terms, it says that the speed in meters per second of a wave is the product of two quantities, the frequency and the wavelength. And I notice there we've got frequency F in our units hertz. And remember there, hertz just meant per second. And then we've got the wavelength, which is expressed in meters. Now, you may not be familiar with the symbol here. This is a Greek letter. This is lambda. Okay, we often use lambda as our wave equation, as our wavelength symbol. Okay, I've seen W used before, but very rarely. So try and use the lambda if you can. If we're putting this into a triangle, well, V is going to go on the top because that's the product, and then the other two are going to go onto the bottom. So we've got F there for frequency and lambda there for our wavelength. And in one form, V is equal to F lambda. This is the most common form of the wave equation. And it's going to be the one that you will be expected to remember and that you will see on, for example, a data booklet. However, there are other ways of doing this. You can rearrange for F and you can rearrange for lambda. Feel free to pause the video just to try that before you see what those look like. Okay, whether you pause it or not, we'll just have a look. If we want F, well, we simply have to divide V by lambda because if we cover up the F on that triangle, we get V over the lambda. And similarly, our lambda, the wavelength, is V divided by the F frequency. Okay, like as I've done before, if you wanted to remember this equation, which you don't tend to do these days, you might want to come up with a mnemonic. This is my attempt. Very fast waves, V equal to F, kind of falls apart because lambda isn't pronounced with a W. But this could be one way of thinking about it, and it kind of makes sense to me because we're talking about speed. Feel free to ignore my mnemonics because they are a bit rubbish usually. Anyway, all we're going to do is we're going to see how this works in an equation setting. And if you're in my lessons, you're going to use this equation to do some calculations. So let's look at an example question. This is a nice one because it's a showing question and it involves using scientific notion, standard form, etc. to prove that the average speed of radio waves is 300 times 10 to the 6. So there we've got an astronaut remaining in communication with the Earth from the moon. We're told the frequency of the radio waves, 90.3 times 10 to the 6 hertz. Now, take a second, that's a huge number. That is 90.3 million hertz. In other words, 90.3 million of these waves every second. And a wavelength of 3.32 meters. And again, sometimes we deal with small numbers and big numbers here. That's the kind of order of magnitude of a couple of maybe the room you're in, or a couple of people from end to end. Okay, it's a kind of relatable height that you might have experienced in your everyday life. Okay, what we're being asked to do here is to show about the speed. Okay, so very simple. We use the formula. Our formula is V equal to F lambda. And then what we need to do, well, you can try it yourself first. Take a second to have a go and feel free to press play when you're ready to go. Okay, I'm assuming you've had a shot there. All we have to do is put in those numbers. Okay, we know that V, well, that's a question mark. F, 90.3 times 10 to the 6, and lambda, 3.32. Quite awkward numbers there, but you'll see that why these are used. Well, if we're doing F, 90.3 times 10 to the 6 times 3.32, you will get in your calculator, something like 299 times 10 to the 6. Now, the question here is asking you to show that is equal to 300 times 10 to the 6. Well, 299 in physics terms is close enough to 300 to be considered the same as 300. Again, you could talk about significant figures here. To one significant figure, 299 becomes 300. And so therefore, that's us proved that the answer there is 300. And I like sometimes write the QED here. This basically means that you've proved it. It's Latin, and I can't remember what it is, so feel free to tell me what it means in the comments. Now you'll notice here this 300 times 10 to the 6 is a value you may have seen before, maybe in a slightly different form. This is the speed of a radio wave. It also happens to be the same as the speed of light. And actually, for any other wave in the electromagnetic spectrum, what we find is that all waves in the electromagnetic spectrum, infrared, microwave, UV, and ultraviolet, etc., gamma rays as well, they will all travel at the same speed, and all at this speed, 300 times 10 to the 6 meters per second. Avid students of physics will understand that this is a really important number as we go to study the contributions of people like Einstein, etc. So this number is going to be a familiar one to those of you who continue with physics, and it's an important one in many of our calculations. So make sure you're aware of this number. All right, that's enough waffle from me about physics. If you have any questions, feel free to let me know. And if you're ready to go, get on with those practice questions. Good luck.